Let's talk about the requirements to be considered large-scale PV and what some of the allowances in Article 691 are. To be considered large-scale PV, as defined in the National Electrical Code, you gotta meet all the following. First is a size requirement, at least 5,000 kilowatts AC generating capacity. We're not talking about the size of the array, we're talking about the size of the power electronics. 5 megawatts AC, and if we go to Article 100, we can find the definition for generating capacity. It is the rated inverter power at 40 degrees Celsius. So make sure you're getting the right specification when you're looking at a particular inverter, at least 5 megawatts AC. The system is not under the exclusive control of the utility. They may have operational input in terms of SCADA systems that can control what's going on with the system, but they do not own it and perform the operations and maintenance, even if they do have that capability. They are not the exclusive operators of it. The system's only accessible to and maintained by authorized qualified personnel. Part of that is having a way to restrict access. Usually that's by a fence. So we're only letting in people that know what they're doing and know how to do it safely. They're performing work on a power plant, essentially. Field applied hazard markings are required. We talked about 11021B in other parts of this course. No differences there. The system, here's a difference, is only interconnected to the grid via medium or high voltage. There's no utility service associated with the building or anything like that. This is direct to the utility at thousands of volts, tens of thousands of volts through some sort of medium or high voltage switchgear, substation, or switch yard. There's no loads. Now, there might be loads that are part of the PV system. These could be things like security systems, lighting, convenience outlets, all of those sort of things that exist because the system exists, but we're not putting the system in to serve loads directly. Of course, once the power gets onto the utility grid, that's exactly what it's going to do, but that is separate from the PV system itself. And then finally, these have to be ground mounted. Cannot be on a building. Now you can put 5 megawatt AC system on a building. You need a pretty big building. You can certainly do that. You can put bigger ones on. There are, absolutely. But the allowances that we'll see in Article 691 for large scale PV cannot apply. This has to be on the ground. It's going to be fenced off. Only people that know what they're doing are going to be getting in there. This is basically a system that is built and operated to make electricity. There's investors, there's loans to repay, there's financing going on, and it's not there to serve a building or a house specifically. Section 691.6 and .7 talk about interaction with the authority having jurisdiction. I mentioned earlier that one of the purposes of Article 691 is to alleviate some of the burden on the AHJ, and this specifically goes into what they may request in terms of an engineered design, an original stamped design from a licensed professional engineer. Right? It's going to be engineered, it's going to have a stamp on it, they're going to have to be licensed in the state where the system's installed, all that kind of stuff. Now, the AHJ may also request additional independent engineer review of this plan set. So a separate independent engineer, it's going to be paid for by whoever's getting the permit here, is going to look at that plan set. This IE, independent engineer, needs to be a licensed electrical professional engineer as well. They're going to make sure that, hey, this design complies with applicable standards, with industry practices. It's going to say this does conform to the National Electrical Code, or it does not, but it's following these alternative methods. It's basically a way to get a second engineer to double check the original plan set, which was already engineered, so that the AHJ does not have to do that work. And then finally, the AHJ can then also request additional IE reports from that independent engineer, maybe a different one, maybe the same one, prior to commercial operation, basically ensuring that the system was installed the way it was designed. We have a plan set submitted. We have an IE that looks at that plan set and says it's valid, and then after the system is installed, an independent engineer also goes through and documents and details that yes, the system was installed correctly following the plan set, or if there were differences, those are valid and those were performed in a way that is safe and effective. So these are 3 different ways along this process that the AHJ is able to rely on outside engineering in order to alleviate some of the burden where, they may be looking at thousands of pages of plan set covering all kinds of details that they may not be experts in. The other thing to keep in mind is this is the electrical part of the system. The electrical system design. Obviously, the National Electrical Code doesn't cover things like the structural component of designing the racking and things like the civil component of, runoff of water and all those other kinds of things that go into a project where a big chunk of land is involved. We're just talking about the electrical here. An engineered design, an IE looking at that design, verifying it is done correctly, and then an IE verifying that the system was installed correctly. So it's the AHJ's ability to request these that is fundamental to the way 691 works as compared to how normally the National Electrical Code is enforced by the AHJ, where they are doing plan set review, they're doing inspections. This is just an alternative means to make that happen. So some of the allowances in Article 691 include things like DC operating voltage. It has to be documented, but we have the capability to do things like modeling the system to determine what that voltage may be, allowing us to potentially get more modules in a source circuit. More power per source circuit drives down system cost. Disconnects and isolating devices are allowed to be remotely located. Distance requirements in Article 690 don't apply as long as there's written safety procedures to ensure that only qualified persons service the equipment. We already said that fundamental to the definition of large-scale PV is it's only accessed by qualified persons, and we're going to have a written plan, the O&M plan, standard operating procedures for preventative maintenance, how we react for reactive maintenance. That is all going to be detailed and documented as part of the system O&M package. Rapid shutdown is required. Of course it's not, right? These systems can't be on buildings. Rapid shutdown is for systems on buildings. There is also an exemption for PV supply station equipment buildings. So you may have buildings that are part of a large-scale PV system. They could be housing power electronics. They could be housing other equipment that's part of the system. Those as well are exempted from the rapid shutdown requirements. And 691.10 says arc fault protection is not required so long as there's a documented fire mitigation plan. So arc fault protection, fundamentally about fires, preventing them from happening. In this case, we are allowed to have a fire mitigation plan. It's probably going to have to be approved by the local fire official, involving things like clear spaces and access and materials that are on hand in order to prevent a wildfire from spreading outside of the fence. Because that's really the issue here. Inside the fence, as long as the fire's contained in there, it's kind of too bad for the people that own the system, as long as it doesn't spread outside that fence. Then it becomes a hazard to other people. So that's what the fire mitigation plan is going to ensure. And this is fortunate because, as we talked about elsewhere, there's not really arc fault protection for the large current, high current DC circuits that we tend to see on these large scale systems. So 691.10, fire mitigation plan in lieu of arc fault protection. We already mentioned that these systems are going to be surrounded by a fence, restricting access to authorized qualified personnel only. Well, we need to consider bonding and grounding that fence because it may be in proximity to energized circuits. So 691.11, fence bonding and grounding. We have to consider proximity to equipment, overhead conductors, and the step and touch potential, the shock hazard that may exist. These have to be considered and documented in the electrical design of the system. And if there's a substation, kind of like the system here, we've got a large PV system, a large scale PV system. It's interconnected via the substation, you can see. Bonding and grounding requirements for fences around the substation, well, there we're going to look to 250.194. So we need to take this into consideration. These need to be documented by the professional engineer. They're going to be part of that stamped plan set. Now, this was a pretty brief presentation. A lot of the things we've talked about in this class are fundamental to designing any size of PV system, any size. But once we get to large scale, there's a lot of stuff going on. These are complex systems, big engineering projects, and it takes a lot of different areas of expertise to make them happen, both from the design side as well as from the installation and execution side, and then the operations and maintenance side after that. So, well beyond the scope of this course. These are complex engineering projects. There's so many details to consider. There's the structural and civil part that we talked about. There's the electrical engineering. You may know how to do a lot of the calcs, but you got to have a professional engineer that can stamp these plans. Medium voltage, a whole specialty in and of itself. The utility, dealing with them, getting interconnection approval, that is a whole can of worms that's going to be specific to projects. Certainly, we're going to have complex data acquisition systems. We may need site power for those systems as well as other needs on site. The security that's going to exist during construction as well as during the operation of the system, and then all the things that go into the pre-planning stage, project management, financing, environmental impact studies. It's almost like we should have a whole course just about that. Maybe someday we will. Maybe I'll catch you there. In the meantime, I hope you enjoyed this, and I will see you around. Thanks.